We've talked about horizontal circles, we've talked about other circles, pendulums, and today we're talking about vertical circles. Have you ever wondered why when you swing a bucket of water really fast, the water doesn't fall on your head? It's cool, right? It's physics. That's the simple answer. Is physics. It's to do with circular motion and the forces that are at play, and the direction in which the centripetal force is acting relative to the gravity, and kind of how fast the bucket is swimming. Right? It's swinging. It needs to be swinging fast enough to generate a centripetal force that is sufficiently high in magnitude to overcome the gravity that's going to kind of cause the water to fall on your head. But that doesn't matter, you can look into that in your own time. We're discussing sort of the maths behind vertical circles and why it's really important to understand them, because at different points in the vertical circle, the F net, the total force that's acting, is different, right? It's not just the same all the time, right? Because it's changing, right? So watch the tutorial video and it will really kind of help you understand what I mean by this.
Alright, so let's discuss vertical circles, because we've talked about horizontal circles, but we need to take some time to discuss vertical circles, and that's primarily because when an object is undergoing uniform circular motion in a vertical plane, there are changes to what I'm going to call F net. Okay, F net, N-E-T, F net. And I suppose when I say F net, I mean the net force that's going on, right? Like, we know that when a car is driving, if we have a car, not the best car, but it's driving this way, and we're going to have an opposing force this way, right? So oversimplified. But what I'm trying to tell you is that we have free body force diagrams when an object is in motion, right? So if we look at scenario 1, we have a bucket which is being swung in a circle, and it's at the base of its movement, right? So I suppose we need to kind of draw a free body force diagram so that we can understand what the net force is. And I suppose in order to do that, we have to ask ourselves which forces are acting. And it should be pretty clear. If you imagine doing this, you're swinging it, when it gets to the bottom, what can you feel as you're doing that, right? Well, you're certainly going to have weight due to gravity. Okay, you're going to have weight due to gravity. Okay, that's a bit rubbish. We can call that the force, okay, due to gravity. We'll call that Fg, which is going to equal mg, okay, because it's weight. And then we're going to have tension in the rope. Now, if you were to imagine swinging that and it got to the bottom, in which direction would that tension be acting? Well, it would be acting upwards, wouldn't it? It would be acting upwards. And we can call that F, let's just call that Ft. Okay, and that's going to be our tension. Alright? So we can say that our total force is going to be equal, so we're going to say that F net is going to be equal to Ft minus Fg, okay, which means that our Ft, our tension, is going to be equal to our F net plus Fg, okay. And then if I wanted to find F tension, then that would be a matter of breaking this equation down a little bit further, where Fg we know is going to be equal to mg, right? So I would need the mass of the bucket, and the gravitational field strength is 9.8, and then F net is going to be F equals mv squared over r. So I would calculate for these two variables, and then I would use this equation to find the tension. And the key step is kind of going from here to here, where we rearrange, okay? But let's move on to scenario 2 so that the situation becomes a little bit clearer, because right now we're upside down, aren't we? Okay, so gravity is going to be acting this way, right? But then where's the tension going to be acting? Well, this way as well, because it's the centripetal force is being provided by the tension, so it's acting towards the center of the circle, right? That's why we have this in this situation over here on the left as well. So in this situation, F net doesn't equal Ft minus Fg. It actually equals Ft plus Fg, right? And then if we rearrange for tension, we see that Ft is equal to F net minus Fg. Okay, so we've got two different situations and two different formulas. Okay, and that's really, really important because that changes the magnitude of the centripetal force which is being provided by the tension in the rope. So when you're doing vertical circles, go away and look at some more examples, but you need to have an understanding of what it is that's going on, right? Okay, sorry, this is just so this isn't too confusing. F net, if we're finding F net, that's going to be mv squared over r, by the way. I know that this looks a little bit confusing over here, but I've just labelled that. But yeah, you can see that the two equations are different, and it's important that we can draw free body force diagrams for something that is undergoing circular motion in a vertical circle. Okay, and we need to be able to rearrange for the tension force. In this situation, that is what is providing the centripetal force.
Okay, so hopefully you guys found that tutorial video helpful, and it's helped you understand what I was discussing earlier, where we have the different forces that are kind of at play at different phases in the circle. It's something that you should definitely look into as well, you know, at different stages, at each different stage, kind of try and get your head around why that's happening and how, and it will be very helpful for you in your exam. In the meantime, please like and subscribe. It really helps us grow the channel and get more quantum content to you guys, which is what we want to do. But in the meantime, I will see you in the next video. Thanks for watching. Bye.